So we're going to talk today a little bit about solving linear inequalities. So before we did solving linear equations, so today we're going to talk about a little bit about inequalities. So first we're going to look at the inequality signs. Now this sign means less than. So the example here is x is less than 1. And what that means is the alligator's mouth, which is sometimes what this represents. People will say it represents an alligator's mouth. And it always is going to eat the biggest one. So in this case, the alligator's mouth is towards the 1, and it's going to eat that one, and it's going to be bigger. So x is less than that 1. So now let's go over to our graph. Now anytime you just have this less than sign, your circle is actually going to be open, like this one. And if it's less than, it means it's going to go towards the numbers that are smaller, and negative numbers on a graph are always smaller than the positive numbers. Well, let's go down to this one, which is less than or equal. So again, your alligator's mouth, x is less than, because it's going to eat the bigger one, or equal. Now the equal sign is this bar down here. That's what represents equal. Now let's go over to this graph. Something that you can notice the difference is that when you've got this equal part here, this part here, that means that this circle has to be colored in anytime you have the equals in your equation. So let's go back up here. This is just a less than, this is less than or equal because the dot is filled in. So let's go up here to greater than. So this is red, x is greater than 1, because again, the alligator's mouth is eating the bigger one. So let's go over to our graph. So it's just greater than, which means the circle remains open. And the graph is going to go towards the greater numbers or the bigger numbers. Okay? Let's go down here to greater than or equal. Again, this graph is red, x is greater than or equal to 1. Now, if you go over to your graph here, greater than or equal means that the circle has to be colored in, and the graph is going to go towards the numbers that are bigger. Okay? All right, so let's go down to solving linear inequalities. So let's go ahead and solve and graph this first equation. It says solve 5y minus 8 is less than 12. So let's go ahead and do that. So 5y minus 8 is less than 12. So is less than 12. Okay? All right, so now what we're going to do, we're going to go ahead and switch colors. Okay, so now what we're going to do is we're going to go ahead and switch colors. So what we're going to do is we're going to actually go ahead and solve this equation. So we're going to add 8 to both sides. Okay, so add 8 to both sides. And then we end up with 5y is less than 20. Okay? Now, we want y by itself. So what we're going to do is we're going to divide by 5 on both sides. So we're going to divide by 5, and we have y is less than 4, because 20 divided by 5 is 4. So I'm going to go ahead and switch colors now. Now we need to actually graph this inequality. Sorry, this line is not completely straight. But here we go. So we're going to start at 0. Okay? We're going to go -1, -2, -3, -4. So -4. We're going to go on the other side. We've got 1, 2, 3, and 4. We're going to just go ahead and put a 4 there. Now, you should put all the numbers here, but for the sake of time, I'm not going to. So this equation reads y is less than 4. So it's not equal to, so that means our circle is just going to be open. We're not going to fill it in. Now, less than means it's going to be less than the number 4. So any number that is less than 4. And that is how we graph linear inequalities. Okay, so now let's go to another one. So our next equation is 2x plus 1 is less than or equal to 6x minus 1. So let's go ahead and just write that out. So 2x plus 1. So 2x plus 1. Okay? Then we've got is less than or equal to, so is less than or equal to 6x minus 1. Minus 1. Okay, so again, we need to combine like terms. So let's start with our x's first. Or actually, let's start with our 1's. So I'm going to go ahead and just add 1 to both sides. Okay? So now our new equation, let's go ahead and cross that out. So now our new equation is 2x plus 2, because we added the 1's, is less than or equal to 6x. All right, so now what we're going to do is we're going to take this variable here and we're going to move it to the other side because we want to combine like terms again. So we're going to minus our 2x. And the reason we minus it is because we do the opposite. Okay, so minus 2x. We can go ahead and cross these out. And our new equation is 2 is less than or equal to 4x. Okay, now again, we want to get our x by itself, so we're going to do the opposite. So this reads 4 times x, and the opposite of multiplying is dividing. So we're going to go ahead and divide by 4, and divide by 4. So we have 2 over 4 is less than or equal to x. Now, we need to go ahead and reduce this. So 2/4 is actually 1/2 because we can go ahead and reduce it. So we can divide the top by 2, divide the bottom by 2, which gives us 1/2 is less than or equal to x. And now let's go ahead and graph it. Okay. All right. So here we go. Here's our graph. Again, sorry, it is not straight. So we're gonna start at 0, and we've got 1/2, 1, 1.5, 2. So let's just go ahead and put -1/2. Okay? And this is a 1/2, 1, 1.5, 2. So let's go ahead and put 1/2 here. Okay? So now if we look at this equation here, it says 1/2 is less than or equal to x. So that means your dot has to be circled in. So we're going to go ahead and start at 1/2, and we're going to circle that in. Now it's less than, so it's going to be less than 1/2. So all the numbers that are less than 1/2. And that is, again, how you graph and solve linear inequalities. All right. So now, let's look at solving compound inequalities. So compound inequalities, it says it's two simple inequalities that are joined by an and or an or. So what that means is, can we go down here? It says 2x plus 3 is less than 5, or 4x minus 7 is less than 9. Okay? So let's go up here first. So when we have an or, what you do is you actually put them on opposite sides. Okay? When you have an and, you actually go ahead and connect them. So let's go ahead and do the first one. So it is 2x plus 3 is less than plus 3 is less than 5. And we've got that magical number or here. Or 4x minus 7 is greater than 9. Okay, so let's go ahead and make sure that we know that this is an or. So what we're going to do is we're going to solve this side first. So we have 2x plus 3 is less than 5. So let's go ahead and take that equation out. So 2x plus 3 is less than 5. Okay? Again, we're going to match, so minus 3, minus 3. We got to match our variables. So we have 2x is less than 2, because 5 minus 3 is 2. Okay, so now we're going to get x by itself, so we're going to divide by 2. We're going to divide by 2, and we've got x is less than 1. So that's going to be on our first part of our graph. Okay, now let's take out this equation over here. So we've got 4x minus 7 is greater than 9. So again, we're going to combine like terms. So here we go. We're going to add 7 because we do the opposite. So this is a minus 7, so we're going to go ahead and add 7. So we've got 4x is greater than 16, because 9 plus 7 is 16. We want x by itself, so we're going to divide by 4, and we're going to go ahead and divide by 4. Then we've got x is less than 4. And this is our second equation. So let's go ahead and graph this. So if you notice on the or, so we're going to go ahead and go back. So here, let me draw our line here. And we're going to go ahead, and this is going to be our 0. 1, 2, 3, 4, 5. I'm going to put a 5 here. And 1, -1, -2, -3, -4, -5. I'm going to go ahead and put a -5 over here. Okay. All right. So now let's go back. So it says this is an or right here. So let's go back up and see if we have or, what it means is that both equations are going to be on the graph, but they're going to be separate. So let's go back. We've got x is less than 1. Again, there's no equals under it, so our circle is going to be left open. So let's start at 1. And x is less than, so we're going to go ahead and go this way. Now this side, and again, it's